June 2015 Core 4, the question 5. Just jump into the last part again. In the first part was done very, very well. The gradient was equal to minus a half. The equation here, few people didn't leave it in the right format, but the equation here was y equals 2x take away a half. And so the last bit, well, you've been given that we've got an x coordinate here and a y coordinate here, so we had to try and put these into that formula there. So we were looking at the sine of q equals 2 lots of the cos 2q take away a half. There, cos of 2q. You needed to remember the cos 2q formula. It's not in the formula book, that one there. That's 1 minus 2 sine squared, 2 sine squared q. And there were 2 of those. Well, now everything's in terms of sine, and it was just a case of dragging it all over to one side. It was 2 times 2 there, so I've got 4 sine squared q's here. I've also got that sine q there, and altogether I can take away a half on this side here, equals 0. Times it by 2 if you want to make it nice, or you could just use the calculators to find out. The 2 answers for that are sine q equals a half and sine q equals minus 3/4. Now, sine q equals a half you've actually done earlier, because we've had that one, was the original bit up there. So it was the sine q equals minus 3/4 that's interesting there. If you want, just inverse sine it and then times it by 2 and cos it. So putting it back in here. And that would give you that x is equal to minus 1/8. Or, if you wanted to, you could actually put it back into that one there again. And that would give you cos 2q straight away, minus 1/8 for x.